You visited the scene at 34 Fairview, correct?
I did.
You stated that you like to visit the scene while you're working as an accident reconstructionist so you can get a better understanding of the data?
I don't know if I'd use the word like, but we want to go to the scene to see the scene.
When you visited 34 Fairview, did you go into the garage at 34 Fairview?
No, I actually didn't set foot on the property.
You didn't set foot on the property?
No, I stayed in the street. It's my understanding there were new owners.
Did you consider the scene limited to the road?
So the access I had was to the road. The laser scanners and the photographs will extend further, but I didn't have access to the interior of the house.
Oh, so you didn't access the entire scene, correct?
In my opinion, I did access the entire scene. I didn't physically step 7 feet onto the grass to the point of rest, but I stood and photographed where that was. I didn't want to trespass.
Where did you understand the body of Mr. O'Keefe was located?
I know it was 7 feet in from the grass. I've seen cruiser cameras showing people around a body. It's slightly north, and slightly south and a little bit west of the flagpole.
But you didn't access that part of the scene that you just described, correct?
I absolutely did. I took photographs of it. I didn't trespass and stand at that exact location, but I stood right there. We scanned the whole thing. The scanner uses a laser beam that goes out, 150, 200, 300 feet. So we scanned all that stuff.
Did your scan topography?
Yes.
Then you know that there is a berm raised above street level, correct? If you did the scan.
Correct.
Do you know the height of that berm?
I believe it's 4 inches.
Nowhere in your report, when you're comparing the height of Mr. O'Keefe to the spoiler, do you account for that 4 inches of the berm, do you?
So yes and no. As I indicated, we don't know exactly where the point of impact is, whether he was completely in the road or up on the berm. But for example, where the tire spins on the Lexus, that could be where she's driving up on the curb. And so then that tire will be at the height of the curb. So if he's standing on the higher part and the right rear tire of the Lexus goes up there and spins, then that would be at the same height. We don't know the exact point of impact. So I don't know whether he was on the road or in the street. Excuse me, on the street or on the side of the road.
Exactly, but when you did your depiction on your slide, and you remember you had the ruler and you measured the height?
So, yep.
Where was it? It was you? Was it you in that slide?
It was.
Where were your feet?
On the ground.
Not on the berm, correct?
Correct.
Okay, so you chose a measurement, which was the ground, to the top for the spoiler, and you took a measurement. And you said that approximates the height of Mr. O'Keefe, correct?
Of the laceration on Mr. O'Keefe.
Exactly, because what you were doing was you were trying to determine and present testimony on whether or not that laceration could be caused by the spoiler, and to do so you had to take measurements, correct?
Correct.
So, you chose to place Mr. O'Keefe in your simulation on the ground. You didn't choose to put him on a berm that would be 4 inches higher, did you?
Nor did I put the Lexus 4 inches higher. I didn't do either one of those.
So the point is, it's certainly possible that if there's 4 to 5 more inches, that would take that eye out of the ability to be hit by the spoiler. Isn't that correct?
No, because if it's 4 to 5 inches higher and he leans his head down or reacts to it, again, we don't know the exact position of his head.
Did you, in your slide yesterday, describe the possibility that his head could be down? As I understand it, you're positioned in that photo just like this. You're not positioned like that in any photo you presented to the jury, were you?
I'm trying to make it clear. We don't know his exact body position at the point of impact, nor do we know the exact position on the ground. So, which is part of the reason why I haven't tried to exactly simulate this, because we don't have enough parameters to do that. So I don't have that information. I'm showing the geometry relative to someone of Mr. O'Keefe's height.
So you don't have the information to do that properly, so therefore you can't conclude that he had a laceration to the eye from the spoiler by your own answer that you just gave, correct?
So it was done properly. We don't have absolute information to say where exactly he was. I'm pointing out that the physical evidence, the height, matches the height of the laceration. That is one data point of many data points.
So you would have to at least concede that the level of his eye could be non-contacting that thin exposure because you don't have information as you just described.
It could be from contacting the ground.
Pardon me?
It could be from contacting the ground. It could be from other things.
But you don't have the information necessary to conclude with any certainty that Mr. O'Keefe at the time of impact had a level of his head in an upright such that it hit that spoiler. You don't have that information, correct?
We don't have that level of certainty. We have that the height and geometry matches.
And you didn't take into consideration the berm, and you didn't mention the berm at all when you were discussing this measurement with the jury yesterday, correct?
That is not correct. You asked me two questions. I absolutely considered the berm. And the second question when I presented it to the jury, I mentioned the berm when we showed the picture of the shoe in the snow, but that was it.
That's my question. I'll ask it a different way. When we were talking not about finding a shoe in the snow, and you mentioned a berm, I'm talking about when you did the measurement of whether or not the laceration could be caused by the spoiler. You didn't mention accounting for berm height when you discussed that measurement with the jury, did you?
That is correct.
Likewise, you didn't present any Newton's second law analysis regarding the front of Mr. O'Keefe's head with respect to whether his head was contacted by that spoiler, did you?
Correct. Again, it was a glancing hit. We wouldn't be able to do that.
Oh, so it's a glancing hit to the front of the head is your hypothesis?
This whole pedestrian impact is a glancing hit.
So you can have your arm to the side like this, with the back of the vehicle coming like this, and you could glance the right eye with the arm out. Is that what you're saying?
That's what my picture shows when I'm standing next to the car. I could probably find the slide for you.
So you didn't do a force analysis to determine how much force would be applied assuming a contact with the right eye, did you?
That's correct.
And force analysis is what biomechanists do, correct? That's what a biomechanist does?
That is part of what
they do.
So I lined up his anthropometry relative to the known height of the vehicle.
You attempted to line it up. That's one method, but another method is to apply Newton's second law like you did to the back of the head when he fell, correct?
Correct, if we had more information.
Mr. Leslie, why don't we break here?
Thank you, Your Honor.
So, jurors, your lunch is here. We'll see you.
The jury.
Go ahead, Mr. Leslie, whenever you're ready.
Good afternoon, Dr. Welcher.
Good afternoon, nice to see you again.
Same. We had left off talking about some examples of Newton's second law and the application of it and the parlance of force equals mass times acceleration. And I now want to continue on with that discussion. It is correct that you can conduct a force analysis on any part of the body, correct?
I mean, it's more difficult on internal with live people. Like if you wanted like my appendix, I really necessarily couldn't.
Let's talk about the musculoskeletal system, the outside bones. You can conduct a force analysis
So your
on any
bones are on
bone.
the inside.
Sir, if I could finish my question, please.
Okay.
You can conduct a force analysis on any bone in the body, correct?
More or less, yes.
So the force analysis I use as a synonym with Newton's second law is not exclusive to the head, correct? You can do it on other bones in the body, correct?
Correct.
On direct examination, your direct examination here, you did not present a force calculation representing what you allege to be contact between the vehicle and Mr. O'Keefe's right arm, did you?
Correct.
And nowhere in your report do you present a force calculation for Mr. O'Keefe's right arm, do you?
Correct. We didn't have enough information to do it.
We're going to get to that.
Okay.
Now, given that you stated that, quote, determining the effects of physical forces on the human anatomy, end quote, is the job of a biomechanical engineer, you must have conducted several force calculations related to accidents involving humans in your career, correct?
Hundreds.
Hundreds. Now, you didn't present a force calculation in your materials, as you've stated on direct, with regard to the arm, and I'll include in the right arm going from the shoulder all the way to the tip of the hand, okay? So that's my definition of a right arm. You didn't present any force calculation on that part of the body of Mr. O'Keefe, did you?
Correct.
Assume, and we're going to apply Newton's second law. Assume Mr. O'Keefe's hand weighed 7 pounds. So that's the M in the F equals MA.
That's not a good assumption.
Well, what number would you like to apply for an M for the hand of Mr. O'Keefe? I'll take any number you got.
Just the hand?
Just the hand.
Oh, the whole arm of Mr. O'Keefe weighs approximately 12 pounds.
Okay, fair enough. So the whole arm, from the shoulder down to the tip of the fingers, is about 12 pounds, right?
Correct.
Okay. So assume that the Lexus SUV was traveling at 20 miles an hour. All right? Under your theory going backwards, 20 miles an hour. And the third variable I'd like to give you is to assume an impact window of 10 milliseconds.
Okay.
Can you calculate the G's of force from that data?
You need more information.
Well, let me ask you this. What more information would you need?
So we talked about the glancing impact.
I'm talking about a force calculation of an impact, not as to whether it's glancing or not.
So you want a direct head-on impact in the arm, not a glancing hit to where the Lexus comes in, hits the arm, and they continue off together?
I'd like to start with that, but just so we can hopefully expedite it for the jury.
Okay.
I'm going to want to get to what you have depicted in your diagram of how to hold the arm out. And that's not a glancing impact. Is that, sir, with the right arm in parallel with the back of the Lexus?
Yes, it is. So really I'm sorry, let me finish, please. What you're concerned about is where the center of mass is. With the center of mass out towards the corner of the car, that becomes a glancing contact. So you don't have a center of mass contact, you have a glancing contact.
Okay, fair enough. So let's start the first force calculation.
I need my calculator.
I'm going to let him use his calculator.
Sure.
Okay,
Tell me when you're ready.
go ahead.
So let's take a scenario
where it's a center of impact,
Center of mass.
center of mass impact, right?
Okay.
Impact to the right arm.
Okay.
Let's start with that one.
Okay. And you want me to use like a 10 millisecond?
Yeah, be conservative. Yeah, let's use a 10 millisecond for
Okay.
the impact window.
Okay. Question?
What do you get for F of force in the F equals M times A calculation?
About 2,188 pounds. I made a triangular crash pulse assumption.
Right, and if you took the milliseconds in half, become less conservative, would you end up doubling the 2188 number?
If you cut it in half, you would double, yes.
Exactly, through a simple mathematical, semi-algebraic application of the numbers, correct? You
Correct.
divide.
We're doing a little simplification in terms of the crash
Yeah.
pulse shape, but generally, yes.
Right. So, but let's take the conservative number, the lower number, 2188 that you came up with. Do you know from the literature, as you did with the head, you went to the literature and said this is how much pounds of force, if you would get to have to cause a break at the occipital bone. Do you know from the literature how much force it would take to break an arm bone?
I have an idea, yes.
What is your idea?
So for a distributed load, such as this, not a concentrated load, you're going to need somewhere between, I've seen, and this is for cadaver tests, a low of like 2,500, maybe a little lower, to a high of 7,000.
Sir, you have switched, haven't you? We're talking about center mass impact. Did you in your calculation just switch to a side swipe impact to
No.
do your calculation? I'm asking about a center of mass impact. How much force would you need? Let's start with the hand. Maybe it's a simpler one. Do you know how much force it takes to break, any of the hand bones, you know what I'm referring to, the phalangeals,
Yes.
the metacarpals, intercarpals?
Correct.
How much pounds of force do you need to break any one of those bones?
Actually, I didn't find any distributed loading on the amount of force. I don't know.
Well, no, I understand, but I'm asking, do you know from the literature, not a calculation, doesn't the literature tell you, can't you go to the literature like you did with the head, and you say, okay, to break the occipital bone, the literature says you need a minimum amount of force of this. I'm asking you the same question for the hand. If you don't know, it's okay, but do you know what the literature says for how much force is needed to break a bone in the hand?
So for a distributed load across the hand, there are distributed load tests that show you need over 300 Gs on the arm to do that. So it would depend on the mass of the hand.
What is the range of force that you would need to break a bone in the hand? Do you know from the literature? If you don't, that's okay.
I could probably figure it out.
How long would it take you to figure it out? Do you know from the literature what that number is?
Not off the top of my head, no.
Is 300 to 400 pounds of force sound right from the literature that it would take to break a bone in the hand?
For a distributed load,
Yes.
such as the taillight, no.
No, not a distributed load. A load from a motor vehicle going backwards.
Right, that's a distributed load.
Right. So you're saying 300 to 400 pounds of force would not be enough to break any bone in the hand. Is that your answer?
So for a flat distributed load, like hitting the taillight, you're going to need higher.
How about another part of the back of the vehicle?
I guess if you hit on the very corner and it wasn't a distributed impact, like if you had a more concentrated impact,
Yes.
that could increase or decrease the amount of force required.
How much would it decrease it from the number you gave?
Depends on what you're hitting, what it's made out of.
The
contact
Lexus
area.
SUV. Let's assume, I'm sorry.
Can you repeat the question, please?
Absolutely. Thank you. Let's assume we're talking about this Lexus SUV. Right? Let me back up. You don't know where exactly
under your theory that there was a contact, you don't know, you testified to on direct, you don't know exactly where that point of contact is, do you?
Correct.
You don't know.
Except it's on the taillight.
Well, you're saying it's on the tail light, but you didn't observe any impact yourself personally, right?
Did I see Miss Reed's Lexus?
You didn't see any impact, right?
That is correct.
So, and there is no first-hand witness that saw, under your view, that a collision occurred. There's no witness to say where the arm was, right?
There's no person that saw it.
Right. And you have chosen a point of contact, okay? You chose that for your analysis, correct?
Correct.
And you picked that location, but it's also possible that under your theory that a collision occurred, that that arm could have been impacted any part of the back of the vehicle. That's possible, isn't it?
That's not probable, no.
I'm asking, is it possible?
Anything is possible. I don't deal in possibilities, I deal in probabilities. It's not probable.
So, but you don't know exactly where the point of impact was.
So within the range of the light and the exact angle of the hand, no, I don't. What I do know is at the rear tail light area.
So your assumption is that it had, that because there's a tail light that is altered, it must have been by Mr. O'Keefe's arm. That's your conclusion, correct?
My conclusion is there are taillight fragments, a broken glass, lacerations to his arm, and his DNA on the back of the vehicle in the area of the taillight.
Sir, and here I'm going to move to strike the DNA part of that answer for obvious reasons.
I'm not going to strike it.
Okay, so you're making assumptions. You're taking what you view to be certain data, and you're coming to a conclusion, but that is based upon circumstantial information, correct? Is that correct?
Are you calling like pieces of the taillight at the scene around his body circumstantial information?
Sir, let me go to the force and go back to the force analysis. Let's go back to the numbers. I want to stay on, if we can, just the calculation. So let's go back to the minimum amount of force you understand from the literature that it takes to break any bone in the arm from the finger up. Let's start with a hand. What's the minimum amount of force that can be applied to break a bone in the hand?
So it depends on the loading. So I don't actually know. In terms of the forearm, I can tell you there's data that shows up to 300 Gs of loading, you will not get fractures. There's one up to 750 Gs showing no fractures for a male of similar height and weight of Mr. O'Keefe.
Thank you.
You're welcome.
So let's take those numbers,
Okay.
okay? You said 300 and 750. Did I hear it correctly?
You did?
Okay, that's the numbers you gave that would break a bone, correct?
So the 300 actually didn't break any bones, I believe. The 750, the one example, didn't break a bone, but as you got above 350, you started to break bones.
So if
300.
you got above 350,
300.
above 300, yeah, because that's what I thought you said the first time. You got above 300, you start to get breaking bones, correct?
Correct.
And so if you take that 300 number and compare it to the 2,188 pounds of force, you have 7 times the amount of force necessary to break the bone, correct, in the force analysis?
No. If you take 300 Gs times a 12-pound arm, you get 3,600 pounds. The calculation you asked me to run earlier gave you 2,188 pounds.
Right.
So you are 1,412 pounds above the force required. Like the tolerance is 1,412 pounds above the force you would say get in a 20-mile-an-hour impact in terms of the fracture forces.
Let's do it this way.
I'm sorry?
Let's do it this way.
Okay.
The force that you calculated from my hypothetical of this Lexus SUV going backwards, you came up with the F number of 2,188, correct?
I'm sorry, I didn't. What was the? You said
2,180.
you said dyslexic. Did you say Lexus? I didn't understand what you said.
The Lexus
My apologies.
SUV that you've been talking about.
Gotcha.
Okay?
I didn't hear
You
it.
came up with a number for F for force of 2,188. Are you changing that number?
Nope,
Okay,
absolutely
so
not.
let's go with your number of force from this vehicle of 2,188. I'm just simply asking, how much force does it take to break a bone in the right arm of a human being? How much force, not acceleration, how much force does it take to break a bone in the right arm?
Sure. So somewhere between 2,500, the one cadaver tested the distributed load of someone of similar size and weight, and actually close in age to Mr. O'Keefe, showed about 7,000 pounds of force to break it.
Let's go to the hand. Do you disagree that the literature shows it only takes 300 to 400 pounds of force to break a bone in the hand? Do you disagree with that?
Your question's too general. I can't answer your question. It depends on the loading. If I take my pencil, which has a very fine point, and jam it through my hand, I can jam it right through my hand because it's a very small point. But if I distribute the load and a broader load, such as hitting a taillight, it takes much more force because the load's distributed across it. It's like if I sit on the corner of my bed. I might sink in this far when I sit on the corner of my bed, but what happens when I spread my load out, when I lay on my bed like this? I don't sink in as far. Has my weight changed? And weight is basically force. No, but I distributed it over a larger area, so for a given force, you get less sinking into the mattress. So if you hit a broad surface like a taillight or a wall like this, it takes much more force than if I were to take a singular small round object and jam it into the hand. That hurts. This does not.
Okay, if you can hear my question, if it's unclear, you tell me. For not a pen, not your bed, but for a Lexus SUV of 6,000 pounds, is there any part of the back of the Lexus in any manner where you can get a break to the hand from 300 to 400 pounds of force?
Any part on the back of the Lexus?
Yes.
Probably.
Okay. So probably, your words, you can get a break to the hand from just between 300 to 400 pounds of force. That's what you just said, correct?
So you're taking the totality of the back of it? Like if you got it stuck in the bumper? Potentially, yeah. But from a taillight or a broad flat surface? No.
I'm not asking about a taillight. Any part of the back of an SUV, you agree that it is probable that you can get a break of the hand bones from just 300 to 400 pounds of force?
Your question is incomplete, right? You said any part of the back, but then you wanted me to not include taillights or not include the rear body panel. If you hit a very narrow part of the car, like say the edge of the tailpipe, that creates much more of a narrow contact. So force divided by area is pressure. So if you have a very tiny area, you have very high contact pressures. And so, but if you distribute the load over a larger area, the number on the bottom of that fraction is much bigger, so your contact pressure drops. So hitting the edge of the exhaust pipe is going to have a much higher likelihood of causing a fracture than hitting flat against the tail light.
Okay, what we're going to do to make this more efficient, sorry. Mr. Wolf, can you pull up a slide from Mr. Wolf's, or Dr. Welcher's presentation for the back of the Lexus, please? The back hatch, and Your Honor, may we publish that?
Sure. Do you know what number though, Mr. Lewis?
Mr. Wolf does, and
And
I
then
know
he'll
you
tell
need it,
us.
so he'll tell me before I publish, and then we'll give you the number.
No, may I look here?
Yes, I'm going to let Dr. Welcher look at his slide
Oh, sure.
here
Yeah.
instead of just up there.
The back hatch, yes. The one measuring the height, maybe. There we go. Thank you. Okay, this is your slide presentation.
Is there any part of the back of the Lexus SUV that has that more concentrated area where if the hand hit it, 300 to 400 pounds of force could break it? Is there any part, for example, the edge of the license plates, above the license plate, the L symbol that sticks out that would be concentrated? Anything you see there could 300 to 400 pounds of force contacting at any of those points cause a fracture of any of the bones of the hand.
So, I don't know how to show this because in the middle photograph, right where that 2 is on the license plate,
Yes.
there's a vertical edge. That area is recessed in. So if you hit right on that vertical edge, that could potentially do it.
That could do it. How about the L of for the Lexus symbol if the hand is there?
No, it's not deep enough. The compliance of the hand is just going to sink into the car.
Is there any other part other than the license plate that the force applied, you would only need 300 to 400 pounds of force to break the hand?
Maybe the exhaust pipe, and potentially if you hand your hand up near the spoiler.
Right, so now let's go from 300 to 400. Let's go to the 2188, which is your number. Use 2188. Is there any place where in 2188 force you could have a fracture of the hand on that back gate?
Just to be clear, 2188 is the number I calculated for you. It's not, quote, my number.
I understand, but we did.
So-
I understand, but we did the calculation. Is there anywhere on the back of the vehicle where 2188 could cause a fracture of the hand?
So that was a forearm fracture tolerance I thought we were talking about, because we used the weight of the whole arm for that.
We did. And my question is there anywhere in the back of the vehicle, in your opinion, that could cause a fracture with that?
I'm sorry, what, to the hand? Just the hand or the whole arm?
I'll take any part of the right arm. You call it the hand, the forearm. Is there any part that could cause a fracture?
So probably similarly, if you got your forearm down near that transition, like, I don't know if you can see the little dot. I'm talking about this area.
Yes.
Right here.
Yep.
So that transition between the two body panels.
Yes.
That could potentially do it. That's back where the reverse lights are. I'd have to look at whether, that would take it before breaking the plastic. And then, again, maybe if you hit the exhaust pipe as well. It's a much more narrow loading condition.
How about the corner of the tail lamp?
The corner of the tail lamp. I suppose if you had just your hand on the very, very corner, potentially.
Potentially. But you didn't do any of that force analysis for this case, did you?
For the hand, no.
But you did it for the head, correct?
Correct. Is that unable to quantify?
You are aware, Dr. Welcher, that Mr. O'Keefe suffered no fractures of any kind in his hand, correct?
So there were no fractures noted in the autopsy report, but they didn't actually x-ray, from the records I've seen, either his hand or his arm. So there was, at least according to the autopsy report, no overt fractures, but the x-rays I saw, none of them were the arm, and the autopsy report said no sternum, spine, I think it said torso. It didn't say that there were no fractures there.
Was there any evidence in the medical records that you reviewed of any indication whatsoever of a fracture in Mr. O'Keefe's hand?
No.
Was there any indication whatsoever in any of the medical records you reviewed that there was a fracture of any bone in the right arm of Mr. O'Keefe?
Not that I saw. Again, it wasn't x-rayed.
Was there any indication in the medical records, in the autopsy that you say you reviewed, of any fracture of any bone anywhere in the body of Mr. O'Keefe?
Yes.
other than the occipital bone or the skull?
There's a couple bones in the skull that are fractured, but other than the skull, no.
Correct. So, are you aware that the medical examiner for the state of Massachusetts, Dr. Sporty Bello, performed an autopsy on Mr. O'Keefe? Are you aware of that?
Yes,
And you're aware of it because you read the autopsy report, correct?
correct.
Are you implying, and it's a question, that Dr. Sporty Bello missed a fracture or didn't look properly for a fracture on Mr. O'Keefe?
No, I'm simply indicating that, for example, a hairline fracture, I didn't see any evidence that they actually x-rayed the structure, so there'd be no overt evidence of that.
There were wounds on the right arm of Mr. O'Keefe, correct?
Correct.
And you are saying that the medical examiner should have x-rayed that to determine whether there was a hairline fracture? Is that your testimony?
No, you're asking me about evidence and proof of absence of fracture. So I would look for an x-ray to see if that was the case. I haven't seen any evidence of an x-ray of the arms.
So it's your position that on every autopsy, there should be an x-ray of every bone in the body, and that the clinical judgment of the medical examiner should not be accepted, and there should be an x-ray of every bone before a conclusion can be drawn that there's no fracture to a bone in the body of the deceased. Is that your testimony?
Absolutely not. Like, I'm an engineer. You're asking me about proof. And so proof is somebody looked at it, somebody took an x-ray, somebody palpated it and found a comminuted fracture. So we're talking about proof.
Sir, I didn't use proof in my question.
Ask me about the opinion of a medical examiner. I'm not a medical.
Time. Only one person at a time. Mr. Leslie, let him finish, and then you can ask the question.
Your Honor, I hadn't finished my question.
Okay, then finish your question, Dr. Welcher. Wait for a question. And let Dr. Welcher respond. It's a nightmare for that.
I understand. I think I've been doing that, but I'll rebuild my efforts. Dr. Welcher, I didn't use proof in my question. I'm going to repeat the question. Is there any indication in any medical record or autopsy report of the deceased of any fracture of any bone in the body?
That was not your original question, but to answer your question, no. Except for the skull.
Except for the skull.
Correct.
Do you understand whether the absence of any fractures other than the skull of Mr. O'Keefe was of significance to the medical examiner, Dr. Sporty Bello, in the conclusion she reached in the autopsy report that you read?
System.
Did you read the conclusions of Dr. Sporty Bello in the autopsy?
I believe so.
Are you aware of whether Dr. Sporty Bello has analyzed whether the injuries to Mr. O'Keefe are inconsistent or consistent with a motor vehicle impact? Are you aware of any analysis to that effect?
So I'm going to see you on this one.
May I, Your Honor?
Yes.
Thank you. Dr. Welcher, I would like to talk now about your paint exercise. You did not present, as you have stated, a force calculation with regard to the arm. You did a paint exercise, and what I want to do is to reference, and if we need to bring it up, sir, to refresh you, slides 103 to 120 of your PowerPoint presentation in this trial. I'll just call it the blue paint exercise. Is that descriptive enough for you to know what I'm talking about?
No. It's not an exercise, it's a test.
Okay, you want to call it a blue paint test?
Sure.
Okay, let's call it a blue paint test. I just want to try to expedite things and use parlance that we can agree on.
Okey-doke.
So your blue paint test involved painting the right rear tail light blue, correct?
Correct.
Positioning the test subject behind the tail light, correct?
Correct.
With the arm held out, correct?
Correct.
And at a right angle, correct?
Correct.
And then the vehicle, the Lexus SUV, is backed into the test subject, correct?
So I ran 3 different tests.
I know. Well, let's just do each one at a time, okay?
Okay, so you're starting with the last one.
I'll start with whatever one you want.
Okay.
How about if we start with the one at 1 mile per hour?
None of them are at 1 mile an hour.
2 miles per hour?
2 miles an hour.
Let's do 2 miles per hour. Let's start with that one, okay? Now, did you conduct that test in an attempt to show that the injury patterns on Mr. O'Keefe's right arm are consistent with being struck by the Lexus tail light on that arm?
So generally, I wanted to show that the location, area, and span over which that headlight covers matches the location and area of the lacerations on his arm.
That's what I want to get to. So you discussed data that you say shows that that you say shows the Lexus SUV was traveling above 20 miles per hour during the period that you allege the SUV made contact with Mr. O'Keefe. Is that correct?
No. Where'd you get that from?
Hold on. Okay. The answer is no. So did you do a test involving 20 miles per hour?
I did some other backing tests.
Yes.
I was looking at how the rear pedestrian system and what warnings you got from the rear pre-collision system, the PCS system.
Let me ask you this. Mm-hmm. Would you agree that you did a blue paint test with the vehicle going at 2 miles per hour? Did you?
Of course.
Do that? Okay. You didn't do a blue paint test with the vehicle going at 20 miles per hour, correct?
That is correct. I was not going to hit myself with a Lexus at 20 miles an hour.
You could have done other tests where the vehicle was going at 20 miles per hour if you used a crash test dummy, correct? You could have done that.
If you use the right crash test dummy, and then to set up the test, because generally you only get 1 or 2 shots at it, as you damage the car, you have to know everything about the parameters. And so, again, pedestrian impacts are so very sensitive to initial angles. If I were to do a test and it was off a tiny, tiny bit, and we got some different results, I would be in here having to defend it. Well, your own testing didn't show it. Point is we don't have enough information to be able to conduct that testing.
Mm-hmm. Your assumption, as I understand it, is that the Lexus was going 24 miles per hour in reverse and made contact with Mr. O'Keefe. That's your analysis, sir.
No. There is not one single slide I have that says this is the speed he was hit at 24 miles an hour.
Do you know? Do you have a hypothesis at what speed you believe he was impacted? Do you have the point of impact?
I do not know the exact speed. We don't know the initial point of contact. We don't know where exactly he was on the road. We don't have enough information to determine that.
Let's talk about the other information you don't have.
Okay.
You don't have the information as to from your alleged point of contact to where Mr. O'Keefe landed. You don't have that information, do you, sir?
I'm sorry, where is my alleged point of contact?
You allege that there was a point of contact between the Lexus, the back of the Lexus, and
Correct.
Mr. O'Keefe, correct?
Right, but I don't know where that is on the road.
Yeah. You don't know that. I want to go through the information that you don't know.
Okie doke.
So you don't have that. You don't have the point of impact. You don't have where in the road there was impact under your allegation.
Those are the same thing.
Right. You don't have where under your view, the body of Mr. O'Keefe landed precisely? You don't have that information, do you?
What do you mean by precisely? We know it's 7 feet off the road. We know it's near the flagpole. We don't know where it started. The problem isn't where it landed. The problem is where it started.
Right, and you don't have that information.
I don't have where it started.
The paint tests that you used, aren't those used, if they're used at all, as an element of physical impact reconstruction, an element, not as the focal point of the test itself?
So that was the focal point of that test. The focal point of the purpose of that test was to show the contact width and location of how someone of Mr. O'Keefe's height, which happens to be me, contacts and where it would contact where the broken taillight was. So no, that was the focal point of the testing. That's why I did the testing. That's why we're calling it paint transfer testing.
Right, but my question is, sir, I understand that you use paint tests as the focal point, but aren't paint tests in accurate accident reconstruction not used as focal points? They're used as supplements to other tests to get more accurate information. Do you agree or disagree with that?
You didn't give me enough information. I can't agree nor disagree. It depends on what you're trying to do.
Let's go to, on direct examination, you testified that after the 1162-2 trigger event, Ms. Reed's vehicle traveled a distance of 87 feet. Do you recall that?
You are mixing up two things. Remember, the trigger is in the middle of the event.
Give me the chart, please. Your Honor, I'll give you the, as soon as Mr. Wolf gives it, the slide 23, I believe it is.
I'm sorry, what slide?
Well, I want Mr. Wolf to go through it to check. Let me ask it this way, see if we can get to it quicker. Do you remember talking on direct about a calculation of 87 feet where you added, there was like a 30-something number and a 50 number and you came to 87? Do you remember that in your slide presentation, sir?
Slide 37, yes.
Right. So, if we could bring up that slide, please, Your Honor, with your permission.
Okay.
That's 36, but okay.
Are you on 33, sir?
No, I'm on 36.
Mr. Wolf, you have 33? If you could go to 33, sir.
Oh, sorry.
Yeah, because that's where your 87 number is, not on the other.
It's on a bunch of slides.
Yep.
Go ahead.
All righty. So if you could zoom in, Mr. Wolf, so Dr. Welcher can see the numbers in the column.
You're going the wrong way.
Yep. They're to the farther to the right.
Oh, I'm not the only one that has problems.
Okay.
You
Sir,
still
do
don't
you
have it.
remember testifying about this? To the farther to the right?
Farther to the right.
Yep.
Keep going. Keep going. Yeah, a
Is
little
that
more.
53 number down there? That column?
Right.
So if
can,
you
we,
take-
can we scroll up a tad so you can see the headers? There you go.
Okay.
No, okay, go ahead.
So, am I in the right column relative to start? Is that the column?
So there's two columns. Like Z is relative to where it started, and then positive is forward, and then as you back up, once you go past 0, it becomes negative.
Right. So what I want to do is have you direct us to the column where you calculated 87 feet.
It's in two spots. It's at the end of column Y.
Right? We go all the way down. Is that in the yellow there? Is that 87, sir?
It is.
Okay, is that the 87 number you were
Hold
referring
on a
to?
second. You asked me to identify it. So then it's see where the one next to it says minus 53?
Yes.
0.429. If you go up, so it's not a little bit down, a little bit, and add, see where it's changing directions at 34.157?
Yes.
You add those two together, that gives you the same result. So it went 34 feet forward and then 50-something feet backwards.
Right. And what is the 87 feet traveled, is that what you're indicating is the distance traveled during the trigger? Is that what the 87 represents to you?
That is so 87 represents the total rearward distance traveled during the trigger.
Okay. So you believe 87 represents the total rearward distance. Did I hear you correctly?
Correct.
Now, can you please...
Hold on, to be clear. So it starts, it pulls forward, then it backs up, passes where it initially started, and goes 53 feet further back.
That's what I want to get to. How many feet did you say on direct, and did you just say now that it went 87 feet in reverse?
Correct.
Okay.
From its furthest point forward.
Well, that's what I want to get to because I want to have this point clear. How many feet do you believe the Lexus went in reverse based upon your PowerPoint presentation? Not when it went forward and then came backwards. How many feet do you believe that vehicle went in reverse?
Your question doesn't make any sense because when it went forward, then it went in reverse.
How many feet do you believe the Lexus went during the trigger?
So it went a total of 80, it went 34 feet forward, then it came back 80, or another 53 feet past where it went.
Exactly. So, you've testified that the 1162-2 trigger event represents a backwards maneuver, correct?
So again, I was clear, it initially pulls forward and then backs up.
I would like you to define, so it's clear to the jury, do you consider the event of 1162-2 just backward movement, or do you consider the trigger to be forward movement and adding to it backward movement? Which one?
So can we pull the slide up?
Sure.
Could you zoom in? There you go. No, go back to the left. So that T in the third column for data ID represents the trigger. If you scroll over a little bit to the right, where the highlighted yellow blocks are, you can see 1 is a forward drive gear, 0 is neutral, 2 is reverse. So that's where it's switched from forward to reverse. I mentioned the brake. So you have it on the brakes coming in, slowing, stopping, going into reverse, and then backing up.
So you conclude that the vehicle for this trigger went 34 feet forward, is that correct?
Correct.
How do you know the vehicle didn't go 150 feet forward? How do you know it just went 30 feet, 4 feet forward? How do you know that?
So the only data we have is this 10-second window. And so we have the velocity when it's going forward. We know how much time it took to do that. So that tells us how far it would travel. Velocity times time is distance.
So are you saying that it is a certainty that it went forward 34 feet and there's no other number of feet it could have gone forward? You're absolutely certain of the 34 number?
No. Again, if you look, see where it says vehicle speed?
I see it.
So at the start of this event, which is the trigger -5, so the trigger is actually where it's triggered, and it takes 5 seconds before, 5 seconds after. But when the trigger happens, it's actually stopped. But the 5 seconds before, it's going 13.6 miles an hour forward. So at the start of the data, it's still going 13.6 miles an hour forward, but it's slowing down. You can see you have the brake, where it says brake SW, which is short for switch. The brake switch is a 1, which means it's on. So when this event data started, it's going 13 miles an hour.
I'll ask the question a different way. Are you certain that the distance traveled forward during this trigger event was 34 feet? Are you certain?
I'm pretty certain during this trigger event.
Pretty certain or certain?
Well, I've checked the math. I've had people check my math. So I try to be as accurate as possible. I would say I'm certain,
Okay.
but I'm an engineer. So there's no absolutes, there's no 100% in my job.
So you're certain of the 34 feet, and is it correct that you're certain of 53 feet going backwards? Are you certain of that, sir?
So backwards from its initial starting position.
Yes.
Correct.
Okay. And therefore you are certain of a total of 87 feet traveled that you have at the bottom in that yellow-orange. You're certain of that as well?
87 feet of backing, correct.
Okay. Now, you also testified on direct, as I understand it, in slide 23, that different numbers represent different gear states of the vehicle, correct?
Correct.
And a 0 represents neutral,
I think it's either neutral or park, but I'm pretty sure it's neutral.
a 1 represents drive,
Correct.
a 2 represents reverse,
Correct.
or a 2 can represent slowing down. Is that correct?
Not for a gear shift number.
So you didn't say on direct that 2 could represent reverse or slowing down.
God, I hope not. It doesn't. So those numbers simply represent, is the transmission in drive? Is it in neutral? Is it in reverse? It doesn't tell you anything about whether it's slowing down or not. But the brake switch and the brake pressure and the longitudinal accelerometer data gives you some information on that.
Okay, so if Your Honor, we could go to slide 30, please. And I want to do it generally. There's not a need to read any specific number. I just want it clarified.
Mr. Leslie, so is this 30 or 31?
I'm sorry, Your Honor, you are correct. It's 31 in the most up-to-date presentation. Thank you. You see all the numbers in blue font on that slide, sir?
I do?
Those are all numbers that you have placed on that slide. Did I have that correct in your direct presentation?
You do?
Okay. So this Excel spreadsheet, there's also numbers in black, correct?
Correct.
So all the ones that are in blue, those are numbers that you have placed into the spreadsheet. Correct?
Correct. The one exception is column N, where it says shift position.
Yes.
I changed green to forward and red to reverse.
So the data in the columns in blue are not from the original data that was downloaded from the vehicle, correct?
Like, for example, if you look at column H, I simply did a unit conversion. So it's the same number, it's just in different units. But the black numbers represent exactly as it comes out of the vehicle, but it's the same number.
All right, that's what I wanted to get to. So for clarity for this slide, when you download this data from the vehicle, what is in black, those numbers just come right out, correct?
Correct.
As they're stated. But the blue numbers, they don't come out like the numbers in blue. You have to do something, some calculation, some application to get to the blue, correct?
Correct.
Okay, thank you.
You're welcome.
Now, we're going to keep that up, Mr. Woke, please. Thank you. And when we need to get to the specific numbers, we'll be fair and make sure you can see them. Now, in these columns, do I understand it correctly that you attempted to account for wheel slippage in the revolutions per minute speed values produced by the car?
Not here. You're looking, this is 1162-1. The wheel slippage occurred in 1162-2.
Okay, and so if we go to a slide with 1162.2, we will then go to the slide you believe represents wheel slippage, is that correct?
There are data points in that represent slippage.
That's my question. In which slide, sir, would you like to pick?
35.
Thank you. So we will go to slide 35. So,
I've highlighted the slippage.
exactly. So you agree that there is data that shows that there is wheel slippage with the Lexus SUV during trigger event. Let's enlarge it for this one here. The trigger event, the number 1162.2, correct?
Correct.
And as I understand it, you testified that this trigger event was caused by a depression of the accelerator pedal at more than the 30%. Is that correct?
It's a transition into reverse and then a quick acceleration exceeding 30%
So let's
in reverse.
Okay, got it. So the accelerator pedal being depressed to this degree, more than 30%, can be the result of wheel slippage, correct?
It doesn't necessarily work that way. I mean, you can have wheel slippage at any acceleration, technically, depending on the roadway. It's just what is in the data that shows that it's slipping. It isn't necessarily because of the accelerator. Normally, that's what causes slippage. But it's the data. When you look at the data, you're like, well, that doesn't make sense. It's increasing in speed, but yet the longitudinal acceleration is dropping.
My question, again, doctor, is you can have an accelerator pedal depressed greater than 30% and it be caused by wheel slippage. That can occur, correct?
The wheel slippage does not cause the accelerator pedal.
I'm not saying a cause and effect. I'm just saying a correlation. Do you understand what I mean by a correlation?
Let me, if I may, try and straighten this out. So, applying heavy acceleration can cause the wheels to spin. Is that what you're asking me?
Yes.
Yes.
Okay, that's all I wanted to get at. Alrighty. So in your review of the materials that are related to January 29, 2022, did you become aware of whether there were, and you said you extensively reviewed documents, did you become aware whether there were people at 34 Fairview?
Yes.
And approximately how many people, without regard to names, just number, how many people did you become aware were at 34 Fairview on January 29th, 2022, the early morning hours? How many people approximately did you become aware were present?
It depends on which time, but there could be as many as 16.
As many as 16. And let's talk about the time period from midnight to 1 a.m. Do you have an understanding of how many people could have been present at 34 Fairview at that time period?
So I'm going to see you at sidebar, Mr. Smith.
Yeah, Your Honor?
Yes.
Thank you. Dr. Welcher, am I correct in my understanding that you believe under your theory, the Lexus for event 1162-2 backed up 53 feet? Am I correct?
No, it backed up a total of 87 feet.
Okay, let's take your 87. It backed up a total of 87, okay?
Correct.
And your further theory is that it did so and reached 24 miles per hour, correct?
Correct.
And you stated you have an understanding of a certain number of people, and I don't want to talk about the inside of the house, but just that were at 34 Fairview between roughly 12 and 1 a.m. Do you have an understanding of that, sir? Approximately.
I believe I do.
And what is that number?
Do you want them, people that were there for that entire window of time, or
Yeah,
just?
Yes, 12 to 1.
So Mr. Alessi, just move to the last question.
Right, sure. So, sir, did you assume that there were cars parked out front of 34 Fairview at that 12 to 1 o'clock window? Did you assume any cars parked out front?
The entire time?
No, I'm just talking 12 to, yeah, any time between 12 and 1. Did you make any assumptions whether there were cars parked out front on the roadway at 34 Fairview? Did you make any assumptions with regard to that?
At a point in time, there was a vehicle behind it.
I'm sorry?
There was a vehicle behind it.
Just one?
That is my understanding, in terms of on the street. is
On
your
the street,
question.
exactly.
Yes.
And what, do you remember the type of vehicle?
Yes.
What kind of vehicle was it?
An F-150 pickup.
Did you have any understanding as to whether there was a Jeep vehicle on the road at that 12 to 1 time period?
I had seen testimony somewhere to that effect, but the majority of the testimony was there were no other vehicles.
But you did see testimony that there was also a Jeep type vehicle on the front, out the front of 34 Fairview between 12 and 1. Is that what you're recalling?
So I'm going to let that answer stand what he's just testified to. Just go ahead and...
Okay, so Dr. Welcher, what I want to do is to have you, using your data, you say 87 feet for the backup, correct?
Correct.
1162 up to 24 miles per hour. Isn't there a likelihood, if there is at least one vehicle out in front of 34 Fairview, that there would be a collision of the Lexus SUV with a vehicle out front?
No, the vehicle had left prior to the end or prior to event 1162-2.
What information do you have with regard to how many vehicles are in front of 34 Fairview at between 12 and 1?
So I have Ms. Reed's interview statements. I have statements of a number of witnesses. I don't know if I'm allowed to say the names.
I was just going to say, let's not just number of vehicles.
Okay, so I have a number of witness statements at multiple statements from the same witnesses at different times, indicating the path and following the Lexus to the house and then leaving before the event.
Assume that there were vehicles, at least one vehicle, parked out front of 34 Fairview. Is there a likelihood that, given 24 miles per hour over 87 feet, is there a likelihood that there would be a collision given the weather conditions as you knew them to be at that time?
Well, the weather I don't think necessarily plays into whether there would be a collision or not, but we know it backed up 87 feet. So again, it goes forward like 35-ish and then back like 60-something. And so if something is within 65 feet of the rear of it, or whatever the numbers are, I need my slides.
It was 50.
50,
Yeah,
57. If something is within that window, then it would hit it.
All right, good. So now let's look at another scenario. If it's going as you describe it, is there a likelihood that the Lexus would also go upon the lawn in front of 34 Fairview?
It depends on where it starts.
You have an opinion, don't you, as to where it starts?
No, I do not. That's actually why I have that diagram showing it off to the side.
That's
I'm
right.
simply showing how far it moved forward, how far it moved back.
Exactly.
We don't know where on the roadway it started.
Exactly. You don't know where on the roadway it started, and therefore all you have is the distance covered, correct?
Correct.
So, but you're saying the distance is 87 feet, correct?
87 feet backwards, yes.
So backwards, 24 miles an hour. Have you ever driven a vehicle backwards 24 miles an hour, sir?
Yes, I think I've driven this Lexus backwards 24 miles an hour.
So if anybody has driven a vehicle back, have you ever driven any vehicle back 24 miles an hour at 1 o'clock, 12 o'clock in the morning?
Probably not since I got out of high school.
Have you ever done it when there's a storm that is beginning?
No.
Have you ever done it when there is less than clear visibility?
No and no.
And have you ever done it when there's low lighting?
Oh, maybe when I've been up skiing in the snow, I've done it. But again, that's been decades.
Right. So 87 feet, 24 miles an hour. Are you saying that in every instance that vehicle will stay on the road, and for 34 Fairview, it wouldn't go up on the lawn?
When you mean every instance, mean like every possible location on the road it starts from?
Correct.
No, there's some spots, if you start here, it's going to go up on the road, on the yard, If you start too far on the other side, you're going to go over into the neighbor's yard. So it depends on where you start.
Right, and so given the conditions that we've just described, right?
Conditions have nothing to do with where you start.
I need to finish my
Hold
question,
on.
sir.
Only one at a time.
Yes, ma'am.
Let him finish his question, please.
Given the conditions that you've described, it is reasonable to conclude that that vehicle, under your parameters, would have gone up on the lawn. Is that a reasonable conclusion?
No.
So you don't think there's any possibility that could occur, a vehicle going 24 miles an hour at this location, 87 feet backwards, in the dark, with wet pavement at a minimum, and low lighting, you don't believe it's possible for the vehicle to, under your scenario, to have gone up on the lawn? That's not
So
possible.
your first question was reasonable, and I said no. Now you're asking possible. It, of course, is possible. Whether it's reasonable or not, I'd have to know the starting position.
Right.
If it's very close to the side, then it could be reasonable. If it's further towards the middle of the road because snow is building up on the side of the road, then it's probably not as reasonable. I would need more information to be able to determine whether it's reasonable or not. It's certainly possible. It's possible it could have shot off into space as an engineer, but not probable.
Oh, you think it's possible that it could have been shot off into space, sir?
As an engineer, it's a possibility.
It's a possibility that
Absolutely.
this Lexus could have been shot off into space.
Highly, highly unlikely. But
Right.
again, you're asking an engineer about possibilities and probabilities.
Let's get back to reality. So, in terms of the Lexus itself, because you, under your method of analysis, don't have the starting point, you can't rule out that under your scenario, the vehicle would have gone up on the lawn. You can't rule that out, can you, sir?
I cannot. No, it could have.
Okay. Now let's go to the next topic. If we could, Your Honor, have Exhibit 168 published in evidence. Now, as I understand your testimony, Dr. Welcher, you believe that it's possible that the Lexus taillight could have caused these wounds to Mr. O'Keefe's right arm. Is that correct?
Correct.
And more specifically, it's your belief that the lacerations would have been caused by the vehicle scratching Mr. O'Keefe's arm as it drives past him. Is that correct?
I don't know. I'd characterize it that way. What happens is, this 6,000-pound vehicle is coming, and he's standing on a, icy, snowy roadway area, and it's going to contact him and move his whole body and induce rotation.
Right. So it's going to contact him and, under your theory, induce rotation. So wouldn't such a movement of the car relative to his right arm result in horizontal injuries to Mr. O'Keefe's arm, as can be seen on his bicep above the elbow?
So could we pull up one of my slides to address this issue?
Sir,
I'd like to answer your question with a slide that I have that addresses this exact point.
I'd like to stay with this slide, Dr. Welcher, and see if you can answer my questions off of this slide. So I'll repeat it.
Sure.
Do you agree that the injuries up at the upper part, where you're familiar with the bicep brachialis?
I am.
And aren't those two up at the top, right over the bicep brachialis?
They're actually about midway between the biceps and the triceps.
Right. So you know which two I'm talking about, the two up there. Can you just use your laser pointer just so we're talking about the same two? Do you have one?
I'll give it a try, but the upper ones,
I know it's not your fault, but
on the
sometimes it
image,
doesn't.
the upper left. I mean,
Yes.
technically, the ones right to the right of that are also on the biceps and triceps.
Right, but
the
I'm talking-
biceps goes all the way to the elbow, so do the triceps.
Right. So I'm talking about the two that are the farthest up.
Correct.
All right. Would you agree that those are in a horizontal orientation?
Generally, yes, which is what you'd expect with your arm like this, and the taillight coming across like this, which is what I showed in my slides.
My questions are trying to keep this moving. I just asked if those are in a horizontal orientation.
Yeah,
Yes
more
or
or
no?
less. They're angled down slightly, but more or less horizontal.
Okay. Isn't it true that if Mr. O'Keefe's arm were to be flexed like it was with the test subject in your blue paint test, the lacerations on Mr. O'Keefe's forearm would be oriented in a vertical direction?
Absolutely not. If you pull up my slide 117, it'll show exactly that it is like perfectly horizontal. When you're standing like this, and this is the tail light, the laceration, when it comes across here and pushes my body, it's going to make a horizontal laceration because the 6,000-pound vehicle is going to push me out of the way. As this pushes me out of the way, it's going to drag and create a horizontal laceration across my arm. This is exactly what you'd expect.
So let's talk about the forearm, sir. We may have miscommunicated. I'm talking about the lacerations on Mr. O'Keefe's forearm now.
So we're switching from the arm to the forearm.
Correct.
Gotcha.
Wouldn't those be oriented in a vertical direction?
No. Again, you have the vehicle, if this is me and this is the car, it's pushing and pushing across like this. And with your arm bent like this, it's going to cause laceration as it pushes my arm away. It pushes like that.
Okay, I
And
got it.
my slide shows this quite clearly.
So you disagree, you do not agree that the injuries to Mr. O'Keefe's forearm under your theory would be oriented in a vertical. You disagree with that. It's just want to get that on the record.
I disagree with that.
Okay. Now, also, do you understand that under your theory of injury here, that there would be injuries caused in two different directions by the same movement of the car? Agree or disagree?
I'm going to say I disagree. You need to give me a little more. You're going to have, again, this is a glancing or a clipping type impact. And so it's going to be it's going to sweep across the arm, which is what causes the horizontal lacerations.
We're talking about a flat surface, right, sir?
Approximately, yes.
And therefore, you would have to maintain contact with the arm as the car moves. Am I correct about that?
Maintain contact with the arm? I'm unclear what you mean.
What I'm trying to do, sir, is to get under your theory, right, given the contact that you've described, what would you expect to be the orientation of the wounds to the upper part of the arm and to the lower part of the arm?
Just like it's shown in this photograph.
Okay. Isn't it the case with your theory that the tail light would have to break, and after the break, the arm would have to maintain contact with the arm as the car moves?
So that is what happens in pedestrian contacts. There is a contact duration. For example, you asked me earlier in that calculation you had me ran, you said 0.01 seconds. That was the contact duration. So when you have things like this, that's why you have to allow, if you do testing, the body to move, because the car is going to hit the body, it's going to cause it to move, the body's going to rotate away, and the car is going to continue on in that clipping type impact. So the arm is definitely in contact with the rear of the car for some time.
That's what I wanted to get to, is simply that under your theory, the taillight would break, and also the arm would need to maintain contact with the taillight area as the car moves. Is that your supposition?
So at a point in time, it'll stop contact. But the 6,000-pound vehicle is going to want to continue moving on. It's going to push. It's going to initially contact the arm and then push the arm away as it rotates the body. So yes, it's going to maintain contact until the clipping is over and the vehicle continues on.
So my next question is simply, how long do you believe the arm needs to maintain contact with the taillight after, under your theory, it breaks to produce those types of wounds that you say came from a taillight?
We don't have enough information to determine that.
Right. You don't have enough information to make that determination, do you, sir?
Correct.
And-
But we know because of the laws of physics that it has to be some amount of time. It doesn't occur instantaneously.
So now we do apply the laws of physics to the right arm that weren't applied before because you applied a paint experiment. Is that correct? You're now applying the laws of physics to the injury to the right arm. But you didn't
No.
do that in your report.
Nope, always applied the laws of physics. The paint experiment, as you're referring to it, was to look at basically the orientation of the scratches that matched this. So that was an engineering experiment to correlate height, position of the taillight relative to height, orientation of the lacerations on Mr. O'Keefe's arm.
You just said, sir, if I heard you correctly, you, to answer my previous question, applied the laws of physics. That's what you just said, correct?
So the laws of physics cover more than Newton's second law. There's a whole law of physics. The whole field of physics is a broad subject. So a simple measurement of height is a physical measurement.
Sir, I have your entire report in my hand, right here. Where in the report do you apply the law of physics to the right arm of Mr. O'Keefe? Where?
So in the paint experiment we did, the laws of physics about gravity, orientation, things like that, I didn't apply Newton's second law as we already went through. But again, those simple positions, arm angles, the possible physical arm angles, those are all generally governed by the laws of physics. The laws of physics are very broad.
Sir, I'll ask it this way. Where in your 14-page report do you even mention the laws of physics related to the right arm of Mr. O'Keefe?
So in terms of applying the laws of physics.
I'm not asking applying, just where in the report is it mentioned law of physics relative to the right arm? Can you point me
I
to
don't know
where?
if I would write a report to say these are the laws of physics. I would say these are the numbers, but for example, the timing in GPS, how a clock times, the concept of a second, what does that mean? Those are all concepts of physics. So the timing, the GPS, the mileage, how we calculate the mileage, those are all based on the laws of physics.
I'm talking about injuries to the right arm.
That's not what you asked. You asked me about my whole report.
Sir, if you could please, I just need to finish my question. Where in your report do you use any laws of physics in connection with injuries to the right arm of Mr. O'Keefe? Can you point me to a word or a page in your report?
Yes.
Where?
2A. 2A Roman numeral 1. 2A Roman numeral 2. 2A Roman numeral 3. 2A Roman numeral number 4. 2A Roman numeral number 5.
Sir, I followed all of it, but what I'm asking about is where in all of what you just mentioned is the word right arm? I'll take what you just said. Where in 2A and all of those is the word right arm? Where is it?
Oh, sorry, it's in number 3.
So let's go to 3. You state the location and orientation of the laceration on John O'Keefe's right forearm and right arm are consistent with the geometry and orientation of the right tail light of the Reed 2021 Lexus LX 570. Where,
Can you read the next sentence?
I'm sorry, is it see PowerPoint slides 102, 120, correct?
Correct.
All right. I want to just start with the report. Did you apply any force analysis to support 3?
So in terms of the force analysis, I did not do an F equal MA analysis, but in terms of, say, the contact pattern, I obviously had to apply some force, even at 2 miles an hour, to do that.
So the answer is, what you cited, number 3, you did not use a force analysis, correct?
So force was applied to my arm in the paint test. I didn't do an F equals MA force analysis.
Thank you.
You're welcome.
So now let's go to the horizontal movement we were talking about with regard to the car. And you can agree or disagree. I'm sorry, we'll take that down. Do you agree or disagree that given a horizontal movement of the car, vertical lacerations would be an inconsistent injury pattern?
So horizontal motion generally will cause a horizontal laceration. You can get what are called stellate, which are a blunt force, and it causes a splitting of the skin as well. But generally, when the vehicle is clipping or running horizontal across it, it will generally cause horizontal lacerations. But when you have a fractured taillight, you can get pieces going off in other directions. So it's not necessarily going to be perfectly horizontal.
So my question is, not with clipping, you keep inserting clipping into my question. My question is this. If you're given a horizontal movement of the car, do you agree that it's more likely than not that vertical lacerations would be an inconsistent injury pattern?
I'm trying to help you, but you got to give me more. So, like, is it a clipping contact or is it not a clipping contact? Is it a direct in the center of the car impact?
That's okay. Are there only 2 variables you need to answer the question?
But this is a good start.
All right. So let me do it this way. You can't answer the question on a general basis of whether there's horizontal movement of a car, whether vertical lacerations would be an inconsistent injury pattern. You can't answer that question without more information. Is that your answer?
So generally, again, horizontal motion should cause horizontal lacerations, but again, it depends on what's being hit.
Okay.
So, for example, if I have something that bends as a result of the impact, it could bend up and create a vertical laceration.
So you would agree, based upon what you said, that generally horizontal movement of a car would be expected to cause horizontal lacerations.
Generally?
Okay. Now, during your blue paint test, the blue paint was featured more predominantly on your upper arm than your forearm. Is that correct?
I think it depends on the test.
Do you want, we bring up a slide? Will that
I'd
help
love to
you?
bring up slide.
We're going to be running the thing, so we'll just bring one up and you tell me whether this slide works for you, sir.
Do you want me to tell you the slide I want?
If we could take a shot at it first, and then we may ask you for it. But I think we've got a slide for you. And what number?
Dr. Welcher,
111 is on the screen, sir. Is the blue paint more predominantly on your upper arm than your forearm? Is there more blue paint on your upper arm than your forearm?
Probably. This is the one where I actually walked sideways into the back of the car. The one where the car is moving is probably a little better representation.
Sir, I'm just asking you a question about this slide. If
Okay,
you could just focus on this slide here, and if you can't answer it, so be it.
I just answered it.
Is the blue paint featured more predominantly on your upper arm than your forearm?
It sort of looked like it. I didn't actually measure the total area of it.
All right. So on direct, you stated that in order for the injuries on Mr. O'Keefe's forearm to have been caused by an impact with the taillight, his arm would have needed to be held outstretched as you did in your demonstration, correct?
You would need some degree of outstretch, yes.
Yes. So isn't that an example of confirmation bias?
No, that's matching the contact pattern to the injuries.
But don't you have to select among other choices this outstretching of the arm? You had to make that selection from among others, correct?
So that was matching the physical evidence on his arm to the physical evidence on the car, and then running a test to see if dynamically those matched up. So it's, I didn't have it hit the exhaust pipe, for example, because there was no assertion to hit the exhaust pipe. There was no damage to the exhaust pipe. So it was based upon the evidence, and the testing was done to test, to use your vernacular, the hypothesis that that's where it came from.
Sir, have I ever asked you anything about a tailpipe in any of my questions today?
Yes.
I have not. I've never
Yes,
asked.
you have. You asked me about the totality of the rear of the Lexus, which includes the tailpipe.
All right. I am not going to be asking any questions that involve the taillight in any fashion. So what I'd like to do is to go back to the question that I'm asking, which is, did you consider, as part of the scientific method, in terms of more than one hypothesis, did you consider in your analysis any other orientation of Mr. O'Keefe other than the one you selected for your paint test?
Yes.
And where is that consideration of other hypotheses stated in any report?
It's not. I was just looking at the damage that was up on the sheet metal.
Okay. So, are you saying that you considered other orientations of Mr. O'Keefe relative to the vehicle as part of your analysis?
In terms of where exactly the hand would be, some slight different angles in the forearm, which is from the elbow to the hand. I did consider that, but all the physical testing is done with the hand hitting the approximate center of the taillight.
Do you have any notes that you took for these alternative orientations?
No, I think I just included photographs of that damage.
You haven't included all, but you consider those other orientations. Anything right?
No, I don't believe so.
Did you consider any other locations of Mr. O'Keefe under your theory relative to the back of the SUV?
Sure. In the beginning of this, I started about, hey, it's all over. It could be anywhere on the back of it. Then whittled it down based upon the evidence, started eliminating various hypotheses based upon the evidence, and came to this conclusion, eliminating hypotheses based upon the taillight fragments near his body, the lacerations, his height, the height of the taillight on a Lexus. So it was an iterative process.
Did you mention any of these supposed hypotheses in your direct testimony?
No, because I was able to reject them. I didn't come in here to tell these people what didn't happen. I came in here to tell them what I believe happened.
Would you agree, sir, that the scientific method earlier has the scientists identify various hypotheses, go with the data that supports it, but we show your math as to why you're rejecting hypotheses. As you say you rejected them, I'm asking for proof that you considered other hypotheses. Do you have anything in writing, any notes at all, any video, any tests that you did, documentation of other hypotheses other than picking this one? Do you have any documentation of that?
So I did a bunch of tests with the Lexus. I did backing tests. I looked at how the rear system worked to see if it would autonomously brake. I confirmed it did not, so I eliminated that as a hypothesis. I tested the steering. I tested the transmission, what 1, 2 represented. So I did a whole bunch of tests on the vehicle.
I understand you say you did a bunch of tests on the vehicle. My question is, did you ever take the vehicle and position yourself or anybody else in various locations to determine whether or not your hypotheses could be properly rejected? Do you have any documentation that you did that?
I mean, I did do 1 static and 2 dynamic tests in very similar positions, though. So I did a total of 3 tests relative to the arm.
Where's the documentation for that, sir?
It's in the file. I gave it to you. It's some of the slides or some of it.
So, Mr. Alessi, I think if we're going to,
I'm going to move on, Your Honor.
So,
okay, Mr. Alessi, hold on, we're going to do that voir dire.
Can I ask,
I just have one other area, Your Honor. I can do it in short order if I could,
Okay.
please.
I wasn't finishing my
Go ahead, finish your answer.
So slides 109, 110, 111, actually through, I guess, 121 deal with the testing of the hypothesis.
We'll come back to this at another time, Dr. Welcher. So what I want to do is to finish up on this point. So is it your testimony that no part of what you did in selecting this area, no part of it is confirmation bias? You say there's no confirmation bias at all in what you did. Is that your testimony?
That's certainly my goal. I try and eliminate all confirmational bias. I didn't start out at this particular location. This is where the physical evidence led me to. So I would say the conclusions are supported by the science.
My question is, did you engage in any confirmation, and this will be my last question, did
The
you
answer is no.
engage in any confirmation bias in terms of how you approach the issue that you have testified about in written reports?
The answer is still no.